Welcome to the DIY Honda Garage channel. The Diagnostic Trouble Code DTC P0443 refers to a malfunction in the EVAP Evaporative Emission Control System Canister Purge Valve circuit. This error may arise due to a variety of electrical issues or component failures within the system. The EVAP Canister Purge Valve plays a critical role in controlling the flow of fuel vapors from the EVAP canister to the engine for combustion, thus preventing harmful emissions from escaping into the atmosphere. It's usually located in the engine compartment connected to the EVAP systems, and a malfunction here may lead to failed emissions tests or increased emissions. Understanding this DTC is essential for resolving any underlying issues affecting the vehicle's performance or compliance with environmental regulations. DTC P0443 indicates a malfunction in the EVAP canister purge valve circuit, specifically indicating that there might be a failure in the valve's operation or its associated circuitry. The main function of the EVAP canister purge valve is to control the release of fuel vapors that are captured in the EVAP canister. These vapors are routed to the engine intake under controlled conditions, allowing for complete combustion and minimizing emissions. The purge valve typically resides in the engine compartment, connected to various hoses and electrical connectors. When this valve fails to open or close correctly, due to electrical faults or mechanical blockages, it can lead to increases in emissions and trigger a check engine light. Several issues could be behind the emergence of DTC P0443. A stuck open EVAP canister purge valve will prevent fuel vapors from entering the engine, possibly leading to performance issues. Alternatively, if the valve is stuck closed, this could result in excessive pressure buildup within the EVAP system, potentially causing fuel vapor leaks. Wiring issues can also create faults in the circuit. Frayed wires or poor connections at any point can disrupt the signal sent from the valve to the powertrain control module, PCM. Short circuits in the wiring loom may also contribute to malfunctions, disrupting normal electrical flow. Identifying these root causes will significantly aid in efficient troubleshooting and repair. The presence of DTC P0443 can exhibit several symptoms that may affect the overall driving experience and vehicle operation. The most immediate symptom is often the illumination of the check engine light, alerting the driver of potential issues. Additionally, if the EVAP canister purge valve is faulty, drivers may notice a decline in engine performance, including stalling or erratic idling. In many cases, failures in the EVAP system can lead to the vehicle failing state emissions tests due to increased harmful emissions. Continuous monitoring of these indicators is essential, not only for performance, but also for ensuring compliance with environmental regulations. Begin the troubleshooting process for DTC P0443 by turning the vehicle to the on mode, which allows electronic systems to engage without starting the engine. Use the HDS, Honda Diagnostic System, to clear the DTC codes stored in the system. Once cleared, turn the vehicle off to lock mode and then restart the engine. It's crucial to hold the engine speed at 3,000 RPM without any load until the radiator fan activates. Then allow the engine to idle. Afterward, utilize the HDS to check if there are any pending or confirmed DTCs. If DTC P0443 is indicated, proceed to the next step. If not, the issue may be intermittent and warrant a check for any loose connections or wiring issues in the EVAP system. For Step 2, ensure the engine is turned off and has cooled down below 131 Fahrenheit, 55 degrees Celsius. This step is crucial for safe handling of components. Next, carefully remove the EVAP canister purge valve while keeping its connector and vacuum hose connected. After this, disconnect the vacuum hose, purge line, from the valve, and connect a vacuum pump with a gauge to the EVAP Canister Purge valve. Start the engine again and let it idle to see if the system generates vacuum. If a vacuum is present, it indicates that the valve is stuck open. If not, the valve is likely stuck closed, directing you to proceed with Step 5. In Step 3, once the vehicle is turned off, disconnect the 2P connector from the EVAP Canister Purge valve. Continuity testing is essential to ensure the electrical circuit is functioning properly. With the valve disconnected, check for continuity between the specified test points using a multimeter. Test point 1 is located at the female terminal number 1 of the disconnected connector, and test point 2 is connected to body ground. If continuity is present, proceed to Step 4 for further analysis. If there is no continuity, the valve likely needs replacement. In this step, utilize the HDS to jumper the SCS, service check signal line. After waiting for at least 1 minute, disconnect the PCM connector E, which contains 80 pins. Check for continuity between test point 1, female terminal number 1 of the EVAP Canister Purge valve connector, and test point 2, which connects to body ground. Having continuity here indicates that the wires are intact, and if there's continuity, the next step focuses on isolating further electrical issues. If not, repair any short circuits in the IPV wire connecting the PCM and the EVAP valve. Step 5 involves checking the voltage in the electrical circuit. Start by placing the vehicle in off mode. Then disconnect the EVAP Canister Purge valve 2P connector. After that, turn the vehicle to on mode without starting the engine. Using a voltage meter, measure the voltage at test point 1 and test point 2. Test point 1 is located at female terminal number 2 of the disconnected valve connector, and test point 2 connects to body ground. If battery voltage is present, you can move on to Step 6. If not, repairs should be made to any open circuits in the IGPS, Integrated Gate Driver Circuit, regarding the valve and fuse connections. For Step 6, again, ensure the vehicle is in off mode and use the HDS to jumper the SCS line for diagnostics. Following this, disconnect the PCM connector E, which has 80 pins. Perform a continuity test between test point 1, the female terminal number 1 of the EVAP Canister Purge valve connector, and test point 2, which connects to pin number 80 on the PCM connector. Establishing continuity here indicates that the IPV, integrated valve pressure line, is intact, and if so, proceed to Step 7. If continuity is absent, address any issues related to opened wires in the IPV circuit. In the final troubleshooting step, verify the internal resistance of the EVAP Canister Purge valve. With the power off and the valve disconnected, measure the resistance between the specified test points. Specifically, test point 1 is the male terminal number 1 on the EVAP Canister Purge valve side, while test point 2 is from male terminal number 2 on the same valve side. The expected resistance should read approximately 23 to 26 ohms when the valve reaches room temperature. If resistance values are found within this range, the valve is functioning correctly. Conversely, if the readings fall outside this range, replacement of the EVAP Canister Purge valve is necessary to resolve the DTC P0443. After completing the necessary repairs related to DTC P0443, it's vital to carry out a thorough verification process to ensure everything was correctly addressed. Begin by confirming that all components have been properly reinstalled and connected. A test drive should be conducted, allowing the vehicle to reach regular operating conditions. After the drive, use the HDS to check for any recurrences of DTC P0443 or any new trouble codes that may have emerged. If no codes reappear, it indicates successful repairs and functionality restoration of the EVAP system. Documenting these findings is also essential for future maintenance and troubleshooting reference. Preventive maintenance is essential to avoid the recurrence of issues related to DTC P0443 and ensure the EVAP system operates optimally. Regular inspections of the EVAP Canister Purge valve and its connections can help identify early signs of wear or damage. Additionally, ensuring that all electrical connections are secure and free from corrosion is integral to maintaining circuit integrity. Performing periodic vacuum tests can help ensure that the purge valve is functioning correctly and not allowing excess pressure in the system. By implementing these practices, owners can extend the lifespan of their EVAP components and enhance overall vehicle reliability. In conclusion, DTC P0443 highlights an important malfunction in the EVAP canister purge valve circuit, a critical component for efficient vehicle emissions management. Understanding the implications of this DTC enables technicians to address issues effectively and implement structured troubleshooting protocols. Each step is built on previous findings, systematically isolating possible causes until the root issue is identified. Following repairs, thorough verification and preventive measures should be employed to ensure long-term reliability of the EVAP system. By staying proactive, vehicle owners can maintain optimal vehicle performance and compliance with environmental standards. Please like and subscribe to the channel. See you next time.